Here I have a container type definition as well as a function f. My container has one constructor bin whose field must be a number. So if I do bin of 1, that gives me a container. Of course I cannot do bin of false because false is not a number. What happens if I change the number to quote a? Again, you should think of quote a as a question mark so that it gets filled in with whatever it has to be. If I say bin of 1, then it has to be a number apparently, so that if I say bin of false, it no longer works because false is not a number. You may notice something strange, which is if I run this again with false first, then the type inference says, oh, apparently this alpha should be a Boolean, and it works, and then when I try with a number, it no longer works. So in this unusual case, the type checker is having to wait until I actually use bin to decide what goes there, but it picks one thing to fill in. This is different from functions where if I say quote alpha, it seems to say that x can be anything, so that I can call f on 1 and I can call f on false. But what's actually happening is it turns out that the caller is able to pick quote a, and the type inference system figures out that f can be polymorphic, that it will be alright for the user to pick, for the caller of f to pick what a is. Whereas no such inference is done for types and type constructors like this. We can let the caller pick, the caller of a type constructor pick, by explicitly putting quote a in the parentheses with the type name. And now this quote a is no longer like a question mark. It is a type variable that's bound all the way inside the type definition. And this really makes bin have the type for all a container a. Right? I can say bin of 1 to get a number container, and I can say bin false to get a false container. So you see two things. I'm able to use number and I'm able to use false. And you can see part of the reason this is allowed is because it doesn't just say container anymore, but container of number and container of Boolean. At each call site for bin, I can pick the particular type that goes there. Container itself is not a type anymore. It's a type constructor, which when combined with some other type, it makes a type. Again, if I take this back out, then we go back to where we were. Before trying bin on either number or Boolean, let's look at its type. It looks like quote alpha, except it's got an underscore. And that underscore is crucial. It means there is no for all alpha on the outside. It just means it hasn't been picked once. And as soon as it's picked, then the type of bin changes to show that instead of quote underscore a, it shows number. We are interested in parameterized types like container a. I can do that. I can even make a list of containers of alphas, in which case f has type for all alpha, gives back a list of container of alphas. Right? If I look at f, it has that type. I can apply f to 1. I can apply f to false. I can apply f to false. Again, though, this alpha here is just a question mark until the type inference engine can figure out that the user can always pick. For example, if I say f false, list of bin 1, now I am constraining f. It no longer has type for all alpha. It has type number, arrow list of container number, because the user of f doesn't get to pick. They're definitely going to, well, right? If this is true, right, and the type checker doesn't try to figure out true or false, right, they're going to get a list of numbers back. They don't get to pick, and so it can't be an alpha here where the client gets to pick.